Dear students, welcome to the course of computer networks. In this lecture, I'm going to explain a very common and traditional, and you can say like a classical topic of computer networks, and that is known as network topologies. The topologies that we are going to cover in this lecture are mentioned here. Let us see the roadmap for today's lecture. We are going to start from the objectives of this lecture, and then we will study different topologies one by one. First, let us see the outcomes. At the end of this lecture, you would be able to differentiate among the different kinds of network topologies, their characteristics, advantages, and disadvantages. First, let us see the first topology, that is the point-to-point topology. But before going into the details of a point-to-point topology, let me tell you what actually topology means. The term topology actually refers to the way in which a network is laid out physically. To put it in simple words, a topology is actually the arrangement with which computer systems and other network devices are connected to one another. You can say it is like the geometrical representation of the relationship of all the links and the devices to one another. So in summary, a topology is how you actually connect the different devices, different system, different hosts, different computers to one another. Okay, so the first topology is known as point-to-point topology. It is the simplest topology that we have, and it actually connects two nodes directly by using a communication link. As you can see here, we have two nodes, 1 and 2, and they are connected by a communication link. So such type of topology, such type of arrangement, such type of geometrical representation is known as point-to-point topology. So you can see a point-to-point topology actually connects any two devices within a network. A device here can be any network device, for example, a workstation, a router, a switch, a server, a client, etc. So it is, you can see, like a one-to-one type of connection. In this case, the available bandwidth of this link is actually dedicated for these two devices that are connected by using the point-to-point technology. So you can say that the entire bandwidth of this common link is reserved for transmission between only those two nodes. If the hosts are connected point to point logically, then may have they actually there are chances that in some scenarios we will have some intermediate devices, but in that case the end host will not be aware of the presence of the intermediate devices. They have to be unaware of the underlying network, and they will see each other as if they are connected directly. So this is the point to point classical topology of the computer networks. Our second topology is known as a bus topology, and this is also a traditional topology, a very common and famous topology in the networks. Bus topology, you can say it was the earliest topology, or you can say that it is one of the first topologies that was used in early local area networks. And it is also a simple network topology. You can say that it is actually a network in which every computer and other network devices is connected to a single cable. You can see here we have three computers and they are connected to a single cable. One long cable acts as a backbone. This is like our backbone because it links all the devices in a network. So you can also say that all the devices, they actually share a single communication line or communication cable, and nodes are connected to this bus cable by drop lines. These lines that actually connect the nodes to the cable are known as the drop line. And we do have another component, that is tape. So a drop line is a connection running between the devices and the main cable, while a tape is actually a connector that either splices into the main cable, or you can say that is like a sheeting of a cable to create a contact with the metallic core. So these are some technical terminologies, but for us the important point is that the devices are connected by using drop line with the help of a tape, which is like a connector. And lastly, both end of this cable, the end of the shared channel or the cable, have a line terminator. This is a terminator and this is a terminator. Why? The data is sent in one direction, and as soon as it reaches the extreme end, the terminator removes the data from the line. One of the big advantage of the bus topology the is the installation of such topology is very simple and very easy. However, the disadvantage is that the failure of this shared communication line can make all other devices stop functions, because this is like a backbone. If this line fail, everybody will affect. So the damaged area reflects signals back in the direction of origin, and in some cases the another disadvantage is that it will create noise in both directions, but that is something technical and we will not go into the details. So for us, the simplest topology that actually connect devices by using a single shared cable is known as the bus topology. We do have another topology, and that is known as the star topology. In a star topology, each device has a dedicated point-to-point link, and we have a central controller, and this central controller in this case is known as a hub. What does it mean? It means that we have different devices, but the devices are not directly connected, not directly linked with one another. They are actually connected individually with the centralized authority controller, which is known as the hub. So a star topology does not allow direct traffic between the devices. All the traffic must have to pass through this centralized authority. Every communication between the hosts takes place through only this centralized hub. And this is another common topology, traditional topology, that is also used in local area networks. Like the bus topology, it is also used inside the LAN, local area network. As compared to the bus topology, and like the bus topology, a star topology is also easy to install. It is less expensive than other type of topology that we are going to study in this course, in this lecture. In star topology, each device needs only one link and one input-output port to connect it to any number of other devices. And this factor also make it easy to install and configure. And also the troubleshooting of such topology is easy. Another type of advantage of the star topology is that less cabling needs to be installed as compared to other technologies, other topologies that we are going to explore in a moment. And also such type of topology is robust as compared to the topologies. How it is robust? Because if one link fail, for example, this link is not working, then it will not affect other links, other system. They are still active. Only this system will not be available on the network. And this factor also lends itself to easy fault identification and fault isolation. Okay, like if this system is not working, then you can easily diagnose this link, this system, and you can repair it. However, one big disadvantage of the star topology is the dependency on this single controller. If it fails, then the whole topology will be down. So if the hub goes down, the whole system is dead. Now let's move to the next topology, that is the ring topology. As you can see, it's formed like a ring. So in a ring topology, each device has a dedicated point-to-point connection with only the two devices on either side. For example, this host is directly connected with these two nodes. This host or this system or device is directly connected with these two neighbors, one on the left and one on the right. So each device is linked to only its immediate neighbors on each side. A signal is passed along the ring in one direction. Okay, like the data flows in one direction from device to device until it reaches its destination. So when one computer tries to communicate or send message to a computer which is not adjacent to it, for example, this computer wants to communicate with this computer number 5. So it is not directly connected, it is not its immediate neighbor. So what will happen? The message will, if it is not adjacent, it will travel through all the intermediate nodes before it reach to the final destination. That is why in this topology we need to install repeaters. Repeaters are used in ring topology. What is repeater? It is a network device, and we will cover it later on in this course. We have different devices, like we have hub, we have switch, we have router, we have repeaters, etc. So repeater is a type of device which is very common in ring topologies. When a device receives a signal and that signal, that data is intended for another device, this device will repeat the signal, or you can say the repeater here, it will regenerate the bits and passes them along the wire, along the connection. You can say like it will strengthen the signal that it received from the device. So when a device receives a signal and that signal, that data, that message is intended for another device, the repeater at that device will actually enhance the signal and will send it out. So if one device does not receive a signal within a specific or specified period, it can issue an alarm, and the alarm alerts the network operator to the problem and also its location where the problem actually happens. So a ring topology is relatively easy to install and configure as like the previous topologies. It is easy to configure, easy to install, and easy to maintain. And when a device in a ring topology receives a signal that is intended for someone else, the repeater will help them out. And we do have the alarms available in such type of topology as well. Okay, in ring topology, it is quite simple to add or delete a device because it will require changing only two connections. However, if someone want to send some data to the last node in the ring topology, for example, we have a ring topology, and this ring topology, let's consider that it has 100 nodes. And if you want to send the data to the last node, the 100th node, then what will happen? The data has to pass through the 99 nodes before reaching to the final destination. That is a problem. So in a simple ring, another disadvantage in a simple ring technology, a break in the ring, such as the station, for example, one station is disabled, it will disable the whole network. How? Let's consider the same scenario. We have a packet to be sent from node number 1 to node number 5, but this node is down. So as our data will goes through this node, but the node is not available, then there is no way to send this data, as the data move only in one direction. So there is no way to send the data to the final destination. So if someone wants, if some node or if one of the station is disabled, then it will disable the entire network. And this weakness can be solved by using a dual ring. If we have a backup ring available, then you can utilize that. That is also costly. So today, this topology is not that much famous. Why? Because we have other higher speed local area networks available, and that higher speed local area network made this topology less popular. Then we have the mesh topology. As the name indicates, mesh. Every device has a dedicated point-to-point link to every other device. Okay, so the term dedicated means that the link carries traffic only between the two devices that it connects. Let me repeat. In mesh topology, every device will have a dedicated point-to-point link to every other device in the network. For example, this device. Consider this device number 1. It has a dedicated link with this device, a dedicated link with this device, a dedicated link with this device, and a dedicated link with this device. This dedicated link means that the link carries traffic only between these two devices that it connects. And here is something interesting that you may try at your own, and that is like how we can actually find the number of links in a fully connected mesh network. And that mesh network has n nodes. To solve this question, you have to think a little. For example, first we need to consider that each node must be connected to every other node. That is what we know by connected mesh network. Every node must have to be connected with any other nodes by using a dedicated link. So for example, node 1, it must be connected to n minus 1 nodes. Similarly, node 2 must be connected with n minus 1 node. Similarly, node 3 must be connected with n minus 1 nodes. Okay, except this, it must be connected with all other nodes. Okay, so for example, in this case, n is 5. 3 must be connected with 5 minus 1, 4 nodes. So there is 1, 2, 3, 4. So that is the general formula. Okay, however, if each physical link, if these links, dedicated links, allow communication in both directions, there is a term that is known as full duplex. We will cover it later on. We have half duplex, full duplex. So full duplex means that communication is possible in both directions simultaneously. Then we can divide the number of links by 2. Okay. So we can say that in a mesh topology, we actually need n into n minus 1 links. Okay. How? You have to practice on it. How is it is equal to n into n minus 1? Don't worry, in the physical class we will solve this equation. So in summary, node 1 must be connected to n minus 1 nodes, node 2 must be connected with n minus 1 node, node 3 must be connected with n minus 1 node. However, if each physical link allow communication in both directions, that is the full duplex mode, we will divide the number of the links by 2, and that will be like n into n minus 1 divided by 2. So we can say that in a mesh technology, we actually need n into n minus 1 divided by 2 duplex mode links. Okay. So let's come to the dedicated nodes concept again. The use of dedicated links actually guarantee that each connection can carry its own data load, and it will eliminate the traffic problem that occur when links must share by multiple devices. You have a dedicated link. You are not sharing this link with anyone else. So obviously it will guarantee the performance. It will eliminate the traffic congestion problem that actually occurs in other type of topologies. So you can say that a mesh topology is more robust. How? If one link is down, is unusable, is unavailable, it does not incapacitate the entire system. The entire system is still working, only one link is down. Okay, and even if this link is down, you can send a packet by using a different route to the destination. So a mesh topology is robust. When every message travels along a dedicated line, only the intended recipients see it. This is another thing. Think about security and privacy. You have a dedicated line. Only you and the destination are able to use that line. So it means this line is more secure and you have more privacy. And also, if this link is not available, then the fault identification and isolation is also easy. And also the modification in topology can be done without disrupting other nodes. If you want to change this link or install another system, then you don't need to mesh up with other nodes or other links. However, the main disadvantage of a mesh topology is the amount of cabling required, the amount of IO ports required. You can see we have to link each and every system with each and every other system in the network. So it means more cables, more IO ports, more installations. So the large number of the wiring can be greater than the available space, for example, in a room. So it would be difficult to accommodate all the cables because every device must be connected to every other device. Installation and reconnection are difficult. It is also difficult and expensive to have redundant connection to every other computer. If you want to have a backup link, then you need a backup link with every other device. So that is going to be more complex now. And it is also difficult and expensive as well to install these redundant connections. One particular example of the mesh topology is the connection of telephone regional offices, in which each regional office need to be connected to every other regional office. Okay, so this was about the mesh topology, and now we have the tree topology. You must be aware of the tree concept in the data structure, which is like a hierarchical relationship among nodes, a non-linear data structure. So the tree topology is also known as hierarchical topology because of the type of uh, of, of of linkages that we have among the nodes. And the tree must have a root node where all other nodes are connected to it, and it actually form a hierarchy. And we have different levels in the tree, and we have different nodes at each level. So this topology actually divides the network into multiple layers, or you can say multiple levels of the network. And also, if you think about the tree topology, you will come to the conclusion that it is actually an extension of the bus and star topologies. Or you can say that it looks like an extended star topology with some inherited properties of the bus topology. Okay, like we have a bus here, and if you see it as a whole, this is like an extended star topology. How? Now let's move to the disadvantage. We are dependent on the root. If the root goes down, then the entire network will suffer. Just like in the star topology, if the hub is down, the whole network is down. So if the root is down, the whole network will suffer. Additionally, every connection serves as a point of failure. For example, if this link, this connection is not available, and you have something to send to this PC, this system, for example, this system number 5, then that is not possible. So a single failure may have to fail to send the packet to another node in the network. However, such topology is easily manageable and they can be easily maintainable as well. However, still we need a large number of cables in this topology as well. Finally, let's move to the last topology, and that is the hybrid topology. As the name indicates, hybrid means a network structure arrangement of nodes whose design contains more than one topology. Okay, that is like a combination of different topologies. So hybrid topologies will have to inherit the merits and demerits of all the topologies that is actually combined of. For example, in this example, we have a star topology and we have a ring topology. So this type of topology where we have more than one topologies is known as a hybrid topology. Now it will have all the merits and demerits of star topology as well as all the merits and demerits of the ring topology. And internet is one of the best example of the hybrid topologies where we have different types or all the types of topologies available. So in summary, a hybrid topology is a network structure whose design contain more than one topologies, and it is like a combination of different topologies. You can link bus topology with the tree topology, star topology with the tree topology, ring topology with the mesh topology, and things like that. And it will inherit all the merits and demerits of the underlying topologies. So this was about different topologies that are actually available for making or forming the networks. Thank you for watching the video. Take care and goodbye.